Okay, so maybe let us see how we handle partial variations, but please don't forget to subscribe to the channel. Partial variation, we have now two constants, the proportionality constants. Why? Because there are many factors in these proportionalities. Now, we are going to see how do we remove those factors and how do we go about it. If you do solve this question, P partly varies because it's partial. So it's partly varies as the square of V and partly as a cube of V. So it means that it's varying 2 times. So it means I'm also going to divide my P into 2 things. I'm going to say my P will be P1 plus P2. The question is, what is P1? So my P1 is the first variation. I don't mean that partly P partly varies as a square of V. So this one is partly varying as a square of V. Now, and then how do I remove this proportionality constant? I'm going to do this a proportionality constant. Because this is P1, I'm going to do this as K1. So my P1 now will be K1 V squared. Then, the second here, I'm telling us that P also varies partly as a cube of V. So now my P2 is varying as a cube of V. To remove this proportionality sign, I'm going to introduce the proportionality constant as my P2 will be K2 now will be cubed. So now, meaning from here, my P was P1 plus P2. So my P is going to be my P1, which is then my P2 to be cubed. Now, from here now we are telling us that from my P equaling to K1 V cubed. They are telling me that when B is 2, P is negative 20. So when B is 2, comma P is negative 20. When I put in here, I have negative 20 equaling to V is 2 cubed. So, if you simplify this, we shall be adding, so we have negative 20 equaling 4 plus cube of 8, cube of 2 is 8. And so you can divide through by 4. So we have negative 5 equaling to K1 plus 2 K2 equation 1. And then they are telling us that when P is 135, V is negative 3. Let us substitute now this condition. So I'm going to be adding now 1 part 5 equaling 2 in here. Okay, 1 into plus cubed. So this will give me 135 equaling 2. When I square negative 3, I get 9 positive. When I cube this, I get a negative 27. Okay, 2. So you see that there I can reduce through by 9. This by 9, we have 5, 15 equaling 2. This will be K1 minus 3 K2. This is equation 2. Now our task here is to solve these two equations. So you see, if I have this, I can solve it with the second equation. So from here, allow me to divide something here. So I'm going to say, if I get this equation minus this equation, I'm going to say equation 1 minus equation 2. So my equation 1 is K1 plus 2 K2 equaling 2 negative 5. Then this one is K1 minus 3 K2 equaling 2 15. So if I subtract here, my K1 will go. Then 2 minus minus, I have 5 K2 equaling 2. Negative 5 minus minus to give me negative 20. So that here my K2 will be negative 4. And then if that K2 is negative 4, we can use an equation. If I put it here, my K2 is negative 4. If I put it here, behind me, now this negative and this negative will be 12, taking this side, so that my K1 will be a 3. Writing it back, it means that now my P will be K1, which is 3, V squared, now plus, but this is going to be minus now, 4V cubed. Now what are you putting? When B is negative, you want the value of P. So want the value of P, allow me to reduce on this arrow here. This is what we're going to do. So they want B, when B is negative 4, they want P. I'm just going to substitute from here. Find P. When this is the relationship, I mean this is the relationship between P and V. Between P and V, so that we have 100. Then find P when B is this. So my P now will be, this is Roman number 1, this is Roman number 2. Negative 4 squared minus 4 into negative 4 cubed. And my P here will be 16 times 3. 16 times 3, that's 48, plus plus 4. This one is giving me 304. As simple as that. So when you come now to this one, once the T is partly constant, now this one is partly constant. So I'm going to say my T is going to be T1 plus T2. I'm going to divide my T into 2. So T is partly constant. So I know it's just partly constant, means it's constant. So my T, this T, T1 now is partly constant. It's partly constant. So I'm going to say partly constant means it's as simple as a constant. So it's going to be K1. Then and partly varies as a square of Q. Now my T2 is partly varying as a square of Q. Remove this now. K2 Q squared. When they say partly constant, you just put that constant there. Don't waste time. Now here we had this because this was variable with a variable, a certain variable, but this is just partly constant. If they say partly constant, just get to one equate to that constant, any constant of the choice. Meaning now my T, which is T1 plus T2, it will be my T1, which is K1, plus now T2, which is K2 cubed squared, and that's my T. Now I want to get these constants out. We come into the information they are giving us. When Q is 2, T is 40. So this is the first information they are giving me. So I have now 40 equaling to K1 plus K2, then 2 squared. So this will give me 40. Then plus when you square this we get 4. K2, and this is equation 1. Then we come to another one. When Q is 3, comma, T is 65. So you put here 65 will be equal into K1, K2 into 3 squared. And so this will be 65 equal into K1 plus when you square 3 you get 9 times K2, and this will be equation 2. So I need to solve these two simultaneously. So now I'm going to say, so this one we have the same coefficient, 1, 1. So I'm going to say equation 2, let's get equation 2 minus equation 1. Equation 2 is K 65. Then equation 1 is K, I'm starting with this side, plus 4. K2 equaling to 40. So if I subtract these two, see if I subtract these two, k1 minus k1 was 9 minus 4, that is 5. K2 equaling to 65 minus 40, that's giving us 25. And so our K2 is a 5. So if our K2 is a 5, you come in any of those formula and substitute. So I'm going to say, allow me to divide this here. So I'm going to say from n. So what is the easiest to use? N. So let me say from 1, from equation 1, so that my K1 plus 4, K2 is equal to 40. So you have your K2 as 5. So your K1 plus 4 into K2, which is 5, is equal to 40. That your K1 will be 20. Now you come back and rewrite this equation because we have now all the constants. So now my T here will be K1 is 20, then plus K2 is 5, and then I have the Q squared. So this is the equation, form an equation for T and Q. This is the equation for T and Q. It should not be having any constants. So then part B, this is part A. Then part B, determine Q when T is 100. So they are giving me T as 100, they want Q. I'm just going to substitute into this formula. So 100 will be 20 plus 5Q squared. Take this side, minus 20 will be equal to 5Q squared. This will be 8. Q squared divided by 5 divided by 5. So that our 16 is equal to Q squared. Get the square with both sides. And you see that our form is going to be giving us Q. So members, that's how we handle that one. Don't forget to subscribe to the channel and wish you the best.